Hello, my name is David Gueorguiev, and I will present a research that I did as a postdoc in Max Planck Institute for Intelligent Systems in collaboration with UC Louvain. Humans constantly deal with contact forces in daily life to perform amazing actions like piano playing or simply to avoid clumsily dropping breakable objects. Considering their importance, it is surprising how little we know about the mechanisms by which these forces are perceived. Perception of normal force, which relates to the indentation of the skin, is especially unexplored, receiving the question of its sensory relevance. In our study, we use a robotic platform capable of modulating normal force while delivering motion against the fingertip with constant speed. This unique tool enabled us to investigate how a sudden change of normal force during dynamic exploration is perceived. To that end, we designed a psychophysical task in which participants had to detect whether normal force had briefly decreased or increased during the trial. Computation of the psychometric curve showed that the just noticeable difference for perceiving changes of normal force is around 19%. Unfortunately, we also observed that the normal stimuli provoked strongly correlated changes of the tangential force, which kept open the possibility that detection actually relied on frictional cues. To test for this possible confounding parameter, we redid the experiment with talcum powder on the fingertip. The addition of talcum changed the frictional properties of the finger surface interaction. If participants had relied on frictional cues, talcum should have impacted their perception of normal force. However, the results of this second experiment showed no change in the perceptual threshold of normal force, while the threshold for tangential force shifted in opposite direction for each of the two experimental conditions of the study. Since Weber's law of perception assumes constant sensory thresholds regardless of the initial intensity of the cue, it is probable that perception in our experiments relied mostly on normal cues. 19% is therefore probably a good estimation of the sensory threshold. In a second task, participants were also asked to categorize whether the force increased or decreased. They performed badly at this task even when the force change was easy to detect. Their accuracy slightly improved with talcum powder, which might suggest a small influence of friction for this task. To sum up, we found that humans are sensitive to normal force changes during passive touch with a GND of around 19%, while smoother friction due to talcum might have helped to categorize the direction of the detected change. Thank you very much.